We're going to be working with special factors to solve equations. And the first example that we're going to look at is a squared plus 2ab plus b squared. Now, if you'll notice, there is no common factor between all three terms, and there is no common variable as far as the factors go, not in numbers and not in variables. You have a's and b, a b, and a b. So there's nothing that we can pull out. So we're going to directly go, in order to factor, into two sets of parentheses. And actually, let me do these in black. Okay, now we're going to put our first one, a squared, a times a. Great. And now we're going to do the back one. Now, once again, we have to figure that these two, and I'm going to use my trusted pencil here, this should be a b and a b. But I have to make sure that this b squared, b plus b, when I multiply, it'll give me the middle term. So b times b gives me b squared. Great. We have accomplished what we needed to accomplish there. Now we're going to check to see if the middle term is actually the multiply the two inner AB, correct? That's 1AB if you want, and the two outer terms in the parentheses, 1AB. Now you could write them as BA or AB. It's the same thing. These are like terms, whether it's BA or and AB, or they're both in the exact same order. When you have one of these and another one of these, that means you have two of them, 2AB. And indeed, this satisfies both things. It has 2AB plus AB equals 2AB, and b times b is b squared. So we're both plus because we want them to be positive, because the middle term is positive, and so is the outer term, the last term, positive. And there we go, we factored it. The final answer being a plus b times a plus b, which we can shorten that by calling it a plus b squared. So the basic shortcut of this is whenever you have a plus b parentheses squared, you take a squared, b squared, you put that in the two outer edges, and then you multiply a times b, and you know that there's going to be two of them, 2ab. And you can see how it works out here, right? A squared, b squared, ab plus ab, 2ab. Okay, so that's the first example. Now let's practice some of them. This is kind of what we use for the rule, the formula. Now let's put it to practice in the real world. So step one, do we have any coefficients that have common factors? Well, this is basically a 1, and 16 and 64 do have common factors, but the 1 is not going to change anything. And they don't have all the same variable that we can factor out. So we have checked for common factors. We're going to create two parentheses. The first term is really simple to do, x times x. Now, the back term is 64. Now, I have to think of two numbers that I multiply that give me 64, that when I add them, I get 16. And that's pretty simple. It's 8 times 8, because 8 plus 8 is 16. And this satisfies both requirements. So plus 8 plus 8. Now, x plus 8 times x plus 8, another way to write it is x plus 8 squared. And if you think about it, 2 times 8, x, is 16x. So 8x times 2, 16x. Okay, so that's kind of still following the same rule. X squared, b squared would be your 8 squared, and then 2 times 8x, 2ab, would give us the 16x. And let's do the third example. Okay, first we have to see if there are any coefficients that they have in common. Well, this is not a 1, so definitely, we should look at that. Are all of the terms divisible by 2? This is your smallest coefficient, the leading one. And yes, all of them are divisible by 2. So it's fair to say that we can pull out a 2. Okay, this would make this 1, and there's nothing else to factor out. And they all share a y. The smallest power is y to the 1. So we can pull out a y to the 1. And we can create our parentheses. And then from there, we'll factor it. Let me do this in black. I always forget the colors. Anyway, so 2 times what gives me 2? That would be 1. And y, which has the same bases this y out here. Y to the 1 times something would give me y to the third. 1 plus what? Because when we have the same bases, we can add the exponents if they're multiplied. 1 plus 2 gives me 3. Okay. Plus 2 times what gives me 12? That would be 6. Y to the 1, to make it y squared, we would have to multiply by y to the 1. Plus 2 times 9. And then y to the 1, it's already there. So we'll leave it like that. And then let me clean it up. So we have 2y. And we have, I did that again, huh? We have y squared plus 6y plus 9. So this is ready to be factored. I'm going to start over here to save some space. Let me write it again. 2y. Aha, I didn't do the black. Y squared plus 6y plus 9. Okay, so let's change and make these two parentheses. Y and y, that's an automatic thing. And the 9, so I have to say to myself, let me do this in blue. What two numbers that I multiply, right, that will give me 9, and then when I add them, give me the middle term, 6. And that's obviously 3 times 3. Very simple to do. So this is plus 3 plus 3. Why did I pick positive? Well, because the middle term is positive and so is the end. Now, if this middle term were negative and this were positive, it would be negative 3, negative 3. But it's not. And there's your answer. It factored, and don't forget the 2y in front. If we were to have this equal to 0 and you were to factor this parabola, you would have, well, or you were to factor this, not a parabola, you would have 3 zeros. 0, negative 3, and negative 3. Actually, that's 2 zeros, right? So anyway, but another shorter way to write this is 2y, y plus 3 squared, because it's repeated. So take a look at that. Make sure that you understand what is going on. We're going to be doing a few other special cases, special factors, but the first one we always start with is a plus b squared. And actually, let me fix this here. This is a plus b squared, which is what we've done with all of these. We get the same factor repeated, and we just square it. The same factor repeated, and we square it. Okay, moving right along to the next special case. This special case, let's see what happens here. So there are no factors to take out, not a's, not b's, and no coefficients, no numbers. So we're going to create our two parentheses, and we get, I'll do this in color. I like my colors. We get a squared, that's a times a. Then we get b squared, that is b times b, okay? But the middle term has to work, right? So this is a positive b squared, right? That means either it's b times b or negative b times negative b. What's going to decide it is my middle term. It's a negative number. That has to be. The only way this could possibly work is minus and minus. And if it doesn't work, then it's just not factorable in that way. You would have to use, which we'll get to eventually, which is the quadratic formula. We're not there yet, but soon. Anyway, let's double check the middle. Using my trusty pencil, I got a squared, b, negative b times negative b, positive b squared. We're good. Now the middle term, which is negative b times a, and I'm going to put this here, negative b times a, and lo and behold, negative b times a again. There are two of them, negative ba, and negative ba. When I add these up, I get negative 2ba, which is exactly what I need. And I've repeated it. So this is another special case. When you have, like the first one was positive 2ba and it was a plus b squared. So if it's a negative 2ab or ba, then it should be a minus b squared. And we're going to do some examples of that. Let's start with example A. First, we check if there is a common factor. Now, I'm going to look at my smallest number, 4. Now, is 24 divisible evenly by 4? And the answer is yes, because 4 times 6 is 24. And 36, is it divisible by 4? And the answer is yep, it sure is, because 36 divided by 4 is 9. So they have a common factor of 4. Do they have a common x? Do they all have an x? Well, there's x cubed, x squared, and x to the 1 power. They all have a common x. We can factor out the smallest power. 3, 2, and this would be 1. So they all have at least an x. These have x cubed and these have x squared, but this one has x to the 1, so we can take out x to the 1. We open up our parentheses, and now we can rewrite this. 4 times what gives me 4? And that would be a 1, just to make it super clear. And x times x to the 3rd. Now this would be, if you want to think of it as x to the 1. And we know when we have the same base and we're multiplying, we can add the power. So 1 plus what will give me 3? And the answer is 2, x to the 2 power, minus 4 times what gives me 24? That's 6. 1 x to the 1 times what gives me x to the 2? Well, it's got to have the same base. And 1 plus what gives me 2? 1. Plus 9 times what gives me 36? And that would be 9. I'm sorry, 4 times what gives me 36? And that would be 9. And x to the 1, we don't write it. Let's clean this up a little bit. Get rid of those 1s we really don't need. It's just to show you where it's coming from. And look what we have. We have a trinomial. We have 4x out here. We are going to, let me write this in green. This is one term. Okay, now we're going to figure out, since the common factors are out, we're going to put these into 2 parentheses, and hopefully it works out. X squared, x, and x. Okay, now the 9. This 9 has to be what 2 numbers when I multiply give me 9, and when I add them give me -6. -6, right? So, well, 9 could either be 3 times 3 or -3 times -3 because it's a positive 9. Obviously, because of the middle term being negative, it should be -3 times -3, which -3 plus -3 is -6. So my answer is -3, -3. And just like our original example, we have a repeater. So we're going to write 4x times x minus 3, repeat in square. Okay? And what was different from the original in this? Just that we had a common factor of 4x, but we should always look for that because once we pull it out, it makes it much easier to factor. Now let's go to example B. Okay, here we go. So we have 100z squared minus 20z plus 1. Not all the terms have z's, so we don't factor out any extra z's. And this has 120 and 1, so there's no common factor that we can pull out for all of them. So we're just going to go ahead and create our parentheses. Now, what times what is going to give us 100z squared? And, well, we got to look at this -20, right? And we also have to consider the 1. I'm going to start, when we're thinking about what times what gives me 100, right? Well, to get close to 20, I'm probably thinking of 10 and 10. So I'm going to use pencil because this is one that could change, and then we'll go back. I'm going to call this 10z and 10z, right? And then the 1 positive could be either, let me call this 10 times 10, right? This could be 1 times 1 or -1 times -1. Okay. The middle term is negative. I'm going to go with -1 times -1. Now let me check my middle term. I should get -20, right? And that's -10z. I think it's going to turn out well for us. And -10z. Again, when I owe $10, I owe $10. That means I owe 20. And it's exactly what I want, -20z. So that does work out. Let's do this in color. Okay. Because it's kind of the answer, -1 and -1. And it just so happens this is exactly repeated. And my final answer is 10z minus 1 squared. And that's how these go. You can sort of figure them out. If you think about, for example, this one, right? 3, right? 2 times 3x gives you the 6. And here, right, it's a similar thing. So this is kind of what it